cleared out. It's still a big construction mess for building just such a small room. I mean, that wall, this wall, and that wall. I mean, two walls really. But I don't know, just guess there's a lot to it when you have to get out all the different things. You know, the studs, which is quick, put that up within a couple hours. You know, and then the drywall, trying to learn to texture it and do all that stuff before painting, and then baseboard, some carpet. Look at this, I put in here yesterday. I was gonna need to get a deal for the chair, you know, from the office supply or whatever. And those things are actually pretty expensive. But went over to the brother-in-law's house to help him with some working on his truck, or so he could tune or change the settings with Forescan. I was like, why don't we just trade some stuff? So I gave him a computer since he needed one, and this was something he had. I kind of cut it with the plasma cutter real quick and throw it down in here, so it'll work. It'll keep my chair off of the carpet. It is got the little, you know, as it goes over the diamond plate, which I don't care when I'm sitting in, it kind of locks it in one spot. And if I really, you know, I could always flip it over too. But anyway, everything else is the same as the last video. I haven't really done anything else. I don't know if I added that other shelf after the last video or not. I don't think so. But hey, man, he's out here. He must get notifications on his phone or something. He's always in here. Yeah, we just gonna do a short video live again, so I don't have to edit or anything. But oh, I will have probably have, if as long as it turned out okay, a new episode of Ghetto Rooftops. Somebody had dropped a request a couple weeks ago, and I remembered that today when I was out with my daughter. So I drove out to those, what is it called, like the Palm, I don't know, it's 35th Avenue in Olive. So I went out there and did a little bit of filming with the drone today. So I'll probably edit that video and get it up. That's not, you remember how many. So it's gone up and down. When I neglected it, it's gone back up. So that's good. I don't even know what it is right now. So anyway, that video will be coming out later. But this I'm just doing live just because the updates. It's just easier just to do it live and not have to edit. Just click done and it's up. So just showing what you're working on. You know how I want to put, I got to clean this up and I want to use this other high wall. I could just use that one, but I want to leave that one running, you know. And I just have it kind of catching the cold air off the Frederick unit tied to this, and it's just kind of blowing it straight down, and then this fan's blowing it in there, man. And remember, this is the Phoenix, Arizona area, so it's, you know, getting up anywhere between 105 110 every day now. I think it was supposed to be in the teens today, but I don't think it really felt that hot. But anyway, so that's blowing kind of on me to make it tolerable. I mean, that's freaking cold ass air blowing out of here right now. I bet you it's like 63 or something. I think we checked the other day. It was like a 30-degree split. Right here, with it mixing all sorts of air, it's like 75, 74. Just right where that is. But it's mixing in, you know, air it's drawn everywhere. So it's not getting all of it. So I'm getting distracted like I always do. That my mind is just all over the place. It's just crazy. But so I think I mumbled the other day about maybe just using capillary tubes, which is what I'm using for the evaporator on the outdoor unit for the heat pump to heat the water. But I was like, it'd be really cool to use an electronic expansion valve from scratch for the first time. So that time is now. So I think I'm going to use this, which this is basically off of a 4-port carrier for, so 4, you know, approximately 1-ton units could be attached to it on a 3-ton unit. I made a cutaway of one of these a couple months ago. So I have this sitting here. I just have a little red piece of tape so you can see like a flag go around when it spins. I just have a program made, and guess what? I was gonna like etch a board maybe, since it was just sucked to have to keep putting the chip down in these you know, little test circuit things you got, prototype, you know, breadboards. So I'm like, I already have several of these extra boards that I made when I was learning to etch these out. I probably made 4 or 5 of these that function, if not more. They already have the LCD connection, so the 4-bit LCD is connected to it. It's already got all that wired up, power in. It's got buttons. So I can change modes right there. I'm changing my steps. Go back down to 1. Up, down, which I'm using that just to rotate this to send out pulses. And just using a couple outputs that are kind of just wired through there and just putting jumper pins on there. So I don't need none of these capacitors. All that was for mostly for the input from 24 volts AC converting to DC through the optical isolators. So just ignore that part. But it makes a nice board. It's already made. And it's got, like I said, the LCD is an important thing. I'm having that all wired up. I don't have to like make a new board for right now. Probably just use this board because I think it's got all the connections I need. I just have to relabel them. Oh, and it has 2 coil temperature sensor inputs, the voltage dividers that plug the 10K thermistors in there. That's what this formula was for, that I actually managed to make work. It's been a little more sloppy since I took it from there and moved it over here. And I've got my new circuit up there. So I'm going to need to read 2 thermistors for superheat correction. The input, which essentially your input basically essentially converts to what your pressure is. And then your output, which is your superheat. That's all like Bone beacon units do and all that kind of stuff. They don't even, the older ones at least, didn't even look at any sort of pressure. They just looked at temperature. And of course, most mini splits do the same thing. They don't even have a pressure transducer usually. It's just a temperature. So you kind of know your suction, not suction, but your low pressure. I guess it is your suction, but anyway, superheat from there. I'm going to put that in there and then just probably write some program, and maybe I might ballpark it and get in this kind of look at what my steps are before the program's done. I'll probably have it hooked up and kind of manually be adjusting and kind of see where a good starting point is, and then maybe program that in. And then I think what a lot of devices do, including like the Bone and stuff like that, and maybe the trains when they first came out with the EXVs on residential stuff, I think if you read the manual, it usually what a lot of them do is once it's adjusted and then it cycles off, it stores in the memory the count of where the EXV was, and then when it restarts the next time, it doesn't go to a predetermined, whatever it was when you first boot up the processor, which always has to have something when you first boot it up. But after it's, held to memory, it will save where it was, and then when it starts the next cycle, it just goes back to that point and then starts adjusting from there. That because your load conditions aren't going to change that much normally from on and off. So I'll probably do something similar. It shouldn't actually take all that much. Amen. See, you got a couple other people in there. Sometimes I have a hard time without my glasses on to pronounce your names right. So that's the idea. So first of all, I just got to at least control the EXV. I got the current set. Like actually it's been on for a long time again, and it's not even warm at all. It feels like room temperature. When I first had it hooked up, it was like getting hot when I was sitting there. So you got to adjust your little current limiter, and I just put it in series with that and kind of saw where it was. And then if you turn it down too much, you eventually won't have the torque. So I kind of know where it is, and if I have to adjust it later, I will once it's all in a charge system. But I think it's going to work because I've wound it shut. And I have an actual working one right here, which we're going to use in a second. So that's going to be kind of cool. But just to show you the cutaway now. And I'm going to open it. And opening means it's going to turn this way. You're looking at the back. You're looking at the opposite direction of what you would. So that screw's got to turn this way to open and back in. Which is, the needle is right here covered up by the tape. But the needle goes in the body. So this has to wind this way and wind down to open. So I'm going to hit open. And it's moving. And I'm doing full steps right now. And I just have it wired up as 4 wire when these are 6. They're just like center tapped, But it actually seems to work real good. And I can change the steps of these 3 inputs, to make it the increments down to full step, which I'm using. Half step, quarter step, 8 step, 16th step. And there's like no need. Using full step, I think gives me it seems to give me taking almost exactly 255 counts to go from lock to lock on this. 255 counts means something because that's exactly how many steps you get, 256 total if you count 0, in an 8-bit word. And other than that, I'd have to go to 16-bit variable, which goes from 255 to 255 times 255, which is like, what is it, 65,000 something steps. I don't need that. I'd want to just keep it at 256. 0 to 255, and that actually worked good. I don't need that. I don't think I'm going to need anything like fractional steps in between for accuracy. I think there's enough within 255 steps or 256 steps from close to open. So just continue open it, and then right there it's pretty much fully. You can see that went in there. It's like opened, and then I'm going to close it. And after we do this, I'm going to hook up the other valve that I have nitrogen hook up to. Kind of show you guys how it works. I just want you to get a visual of what it looks like inside a stepper motor, and that's it. So as I said, this is the dome of a EXV electronic expansion valve. I just have it taken out. This little needle, pintle, whatever you want to call it. It's pintle is like a fuel injector thing, but you know, it's a needle. It turns, doesn't, I guess, move like a cylinder, but it just unwinds to allow refrigerant to go through. It's just same thing as another expansion valve, you know, mechanical ones or whatever, but except for it's just rotating. I'm gonna try to get this to sit up here. I'm trying to keep this here. I had it hooked over here when I was doing my test, but I'm trying to get it so this and the LCD is in the same placement. So right here, this is open. And this hose is fighting me. I brought in a tank of nitrogen just to mess around. So there's pressure on this, and I don't have the pressure cranked up a whole lot. I don't want to go through all the nitrogen, but it's enough to definitely flow, which you're gonna see here in a second. And nothing's coming out right now because it's closed. So it doesn't seem to be closing all the way. I don't know how good the seal is in there. I might put some bubbles on there or a balloon or something and actually see if it shuts down completely. I think it's enough that I could use this in place of a solenoid and maybe use 2 expansion valves for the 2 evaporator idea, indoor-outdoor, for summer-winter operation of my water heater heat pump, where I don't want to blow cold air here in the winter. So I think I'll just install 2 of these off the common liquid. One's going to go to the high wall in here, and one's going to go to the coil out there. And so I'll just have to just do something to with 2 of these steppers, and just the outputs it'll switch to it'll close one and then modulate the other one. Or probably don't even do that. I could probably just use one and just go out there and physically wind it down, which I'll probably have it always do that when you first power it up, just to zero itself after loss of power, and just unplug that EXV and then plug in the other one. That's probably what I'll do, because I only need to change seasons once, really. So, yeah, man. So let me start opening it. You're gonna hear this nitrogen coming out of here as the counts are opening. So it's coming out. Then I can. That's pretty much all the way right there, 255, and then I can close it back up. You can hear it modulating now, you know, restricting it. So as it normally runs and you get your pressure drop across here, you know, it'll just need to modulate a little bit, you know, to adjust the superheat. Now, as I'm pushing and holding this, it's doing jumping a bunch of steps. But when the microprocessor is controlling, it'll be more slower increments. And if I needed to, I could just, like I said, put more increments in there, or resolution, but I don't think I want to. I don't think I need to, so. Anyway, it's closed again. So that's the idea. And open it up again, you get so much, and it starts, you can hear it a little bit right there. I could change the regulator. Now if I hook this up to a reefer tank, so you can really see it does make a difference when I turn the flow up, the pressure up. Where when I had that regulator turned way down, it seemed like it didn't have as much control, because I had it restricted enough that once it opened up probably a quarter of a turn, there wasn't much there after that. It's just because I had this cranked down. But once refrigerant's flowing through there, then you'll probably be using more. You'll get more resolution. I don't know what I would say, but it'll make more of a difference, as it's opening. So yeah, so that's gonna be kind of cool. Close that all the way. That's the idea. So next thing I need to do is make a circuit board, just a small one to drop one of these little driver boards on. Make sure this thing ain't hot. Nope, not at all. Probably won't need a heat sink on that. It's hard to get this thing to sit here. I just need to make a board to house that and make the interconnections. And up here, just kind of what I got so far. This was existing. I left this on here because it's how it was on my last project. And the buttons I left in there. And then I remapped some port outputs. RC5 is going to the step. And it goes through an optical isolator. I probably almost could just use a transistor just to pull up resistor. So it's your step input, you pull it up, and then every time you ground it, it advances a pulse. I've got these optical isolators so cheap, a whole bag of them. It's just always easy to throw them in and everything, and it isolates this from this. And then direction, I didn't use one, but it's just a logical input too. I really didn't need one here, I don't think, but this direction, that's what rotates. So when right now, I'm just pushing my buttons. When it goes to different subroutines, it just changes this from high to low. So that's what different direction. And each, like I said, a full step. So every one pulse I get gets a one step on the stepper motor. Here's the output. The stepper, this is the stepper motor. I think that's from a Carrier mini split that I took apart. And kind of how I have it wired. This is that red driver board and how it is. Got 5 volts for logic, 12 volts for the motor to drive the motor. Yeah. And if you ever need more power for like a motor, you can always change it to like 18 volts or whatever you want, but 12 seems to work. So, and then of course the LCD up there. But that's it. I kept some of this old stuff from before, just so I can remember on certain things how I was doing things. But there's like your stepper, the actual stepper motor I'm using. It's center tapped. Red goes to blue and yellow, and they're like this. And then brown goes to orange and white. Orange and white, so they skip. So you can, these are center taps, like I said, so red goes to where they go, blue and yellow. But instead, you could just ignore these 2 wires and just use these 2 and go all the way across the coil winding. So basically, like red's like center tap to this, and brown's a center tap to the other one. Don't need it as long as you have enough torque, and you usually do. So then you can wire this 4 wire instead of 6, and then one's going across, 1A and 1B, and the other one's going across 2A, 2B. And I had to just crisscross this because I realized the way the wiring is, it's not like 1 and 2 inside the stepper motor wiring. Or how the plug is, it's like 1 and 2 or whatever. They kind of skip, and you can see that here because orange and white are 1. See, they skip, and then blue and yellow the other one. I don't know. It's just the way they wired it. So I had to kind of do that. This is the other board. So it's kind of nice having the dual monitors up in here. I could kind of look at that. I actually put this old Samsung laser printer up here. I have to keep unplugging it because it keeps like chiming my USB disconnect over and over randomly. I don't know why. Used to not do that years ago. But when I plug it in and then hit print, it works. And actually, I printed all this out. That printer has sat for several years, and it didn't print any garbage sheets. It printed all of this out fine, and that's all refilled toner. Like, when I bought that thing years ago, we refilled the toner maybe once, and after that I bought like the toner in a bottle, and you just pull the plug out on these things. And if you don't have a plug, you melt a hole with the kit you buy and put a plug in it when you're done. Dude, I was refilling that thing for years when I used to print this stuff out. And now my color printer upstairs, I've been doing refills in it for several years now, so I stopped really using the toner one. I mean, it's good for speed, but I didn't need to like keep 2 printers going, when I was able to refill each one for cheap, including the color one now. And now I put those refillable not bottles. I've been refilling the stock cartridges, but I finally got to the refillable cartridges. They're like clear or whatever with a little pad in there, but they're made to be filled with plugs on the top. I put those in my HP printer now. So, thanks, but anyway. since I was putting this back together, I thought I'd try it, and it still works. So, a couple of connection glitches for some reason. But that's it. I'm going to clean this up. Probably put the nitro away, but that's it. My water heater just kicked on. And the battery was fully charged. See, it was 56, now it's 55.8. And the sun went down, I believe it is 6:30 right now. Probably got a little bit of sun. It actually shows sun coming in. It shows sun going here. And it shows it drawing off the sun and off of the batteries because the sun's way too down. Oh, yeah. Solar's down to 230 volts. So it's way under. Not way under, but it's under. It's not able to power everything on its own at this time of day. And batteries are using 600 watts out of the battery. So it might be in or using a kilowatt out of the inverter. So kilowatt out. Take it. So it's 400 watts from solar and 600 out of my lithium batteries up there that everybody keeps freaking about because they're not encased, but I'll do some. Yeah, 1 kilowatts what everything's drawn, which is a fifth of the rating of that solar inverter charger hybrid thing that's powering everything in here. Like I said, it's almost 100 watts just for this light. So bouncing between 1 and 1.1. See, now it's staying under a kilowatt when I turn off this LED light. Keep the light back on. Those are bright. And you know what? Since I've been sitting out here, I haven't been going, man, I wish I had another light. Because when I was out there working right there, it was kind of like hard to get good light where I was. So, anyway, those are nice and bright. Those are, and diffused too, because those are like some you add on to an existing. You got to change the ballast or something, or maybe keep it, I don't remember. My friend put that one in there for me. It's like the existing fluorescent device there. But this one here, I've got a Harbor Freight. It does seem to have some pretty good diffusing because you don't realize it's an LED looking at it. There's no real color bars in here that I could see like there is on that one. But if you look on my wall here, there's color bars coming out from that freaking light. And here it looks way more natural. It's a nice white, bright light. So working pretty good. Anyway, yeah, as I said in the last video, I'm going to try to keep this from getting too messy, but I'll keep probably adding things around. But I mean, you know, adding shelves is the name of the game, and then some of this stuff, you know, as I'm working on things, I could kind of put it in these different containers and kind of put it up there. I almost could use another. I was going to put another one right here in line with there, and maybe bump this down a little bit. But I don't know. It kind of. This is the argument of looks and function. Looks better opened up right there than I think it will with another frickin' shelf right there. It'll look funny. But the function would put that shelf right there. But I don't know. I kind of like it about the way it is right now. So I was thinking of putting a shelf across that way, and I might. But I wish, you know, if I would have known how these were going to be in level, I would have put that one in line with it. Dang. But anyway, yeah, hindsight. So I don't know, but I'm thinking the high wall, that one right there might go right. Dang. Yeah, I can. Might put the high wall right here is what I'm thinking, rather than over there. So it can't trip water or nothing. Put it right here and just, I think I can just pop the line set out right here in the drain. Make one hole there. And go down. It's a different expansion valve. That's the same one, is it? But anyway, that's what I'm thinking. This is mounting it right here. So it'll be just above this door. If it leaks water, I'll know it. It's going to start dripping right there. And once I get that hooked up, then I'll put my door on. It'll be nice and cold. It does feel good standing right here where this cold air is, but it's like that Frederick unit, you know, goes up to 16,000 BTUs. It's probably ramped up right now. It's like I can use less than a ton to cool that room if I had it closed. Easy, actually. So. All right. It's supposed to be a short video. See if anybody's seen anything. Goodman bashing. Yeah, I did some Goodman bashing in the drone video I took today of the ghetto rooftop. So watch for that later if I get to editing that. maybe I'll get on that a little bit here. So don't forget to like and subscribe, do all that stuff. Hopefully this progresses and it doesn't become one of those projects that just gets pushed aside. You know, finish it, especially since I need it. So be looking for that. Probably get my little mill thing or whatever you want to call it hooked up somehow over here. Maybe I'll put it on this little, put it on here. That's what I should do. I could wheel it right here. Dude, that's actually what I should do. I was thinking put it on a shelf over there. I should put it, just set it on here, wheel it right here, so I can, and just having a USB extension here and plug it into my computer, and that way I can see the monitor and see it and do all what I need to do with this computer that's already set up to run that. So, all right, now I'm going for real. Like and subscribe, do all that, share. Catch you guys later.